Okay, in this video, we're going to work a bunch of example problems related to geometric sequences. There are going to be different kinds of examples. So by the end of this video, you should be much more comfortable understanding geometric sequences and working with them, and from all angles, from any perspective. So this should really help your understanding of geometric sequences. So first, problem: determine whether the sequence is geometric. If so, find the value of r. Okay, so a geometric sequence, the key feature is that to get each term, to get the next term in the sequence, you're multiplying by some constant value, and that value is called, they label as r. Okay, that's how you know you have a geometric sequence. So in other words, like to go from 4 to 20, we multiply by what? So 20 divided by 4 is 5. Okay, so we should, if this is a geometric sequence, because we don't know if it is, the question says we need to determine if it is, we should be multiplying by 5 to get from 20 to 100. 20 times 5 is 100. To get from 100 to 500, we're multiplying by 5. So this is a geometric sequence with r is equal to 5. Okay, same type of problem. Determine whether the sequence is geometric. If so, find the value of r. So to get from 7 to 14, we multiply times 2. To get from 14 to 42, 14 times 2 is 28, so we're not multiplying times 2. To get from 42 to 88, let's see, 42 times 2 is 84. So it's not the same, it's not a common factor you're multiplying by here, so this is not geometric. So there is no r. Okay, determine whether the same problem. Okay, so let's see. You need to use your algebra skills here. When we go from the square root of 5 to 5, we're multiplying by what? Square root of 5, right? Square root of 5 times square root of 5 is 5. 5 times the square root of, or to go from 5 to 5 root 5, you're multiplying by root 5. Okay, so now let's say we multiply by root 5 again. 5 root 5 times root 5. Root 5 times root 5 is 5. 5 times 5 is 25. So you're multiplying by root 5. So we're multiplying by the same factor here. So yes, this is geometric, and the r is equal to the square root of 5. Okay, so new question type. Write the first 5 terms of the geometric sequence based on the given information about the sequence. So we know it's a geometric sequence because it's telling us that it is, and these are some parameters of this sequence. So okay, you could have the a sub n for a geometric sequence memorized, but you should really just be able to reason what it is on your own. Okay, it's telling us we're starting at a1. You don't have to start at a1. You could derive a geometric sequence for any starting index. You just have to use your intuition to write the formula. But if we're starting at a sub 1, what is the formula, the a sub n, for a geometric sequence? Okay, well, you're multiplying by, each time you're multiplying by this factor r. Okay, right? So like you've got a1, and then you've got r times a1 is the next one, right? You multiply r times a1, and then the next term you're just multiplying r times this term, so you just get r squared times a1, and then r cubed times a1, right? Like if you divide r squared a1 divided by r1, you get r. R cubed a1 divided by r squared a1, you get r. So this is what this is like the general form of a geometric sequence. So we've got, like, okay, so trying to write this out, we have an a1 in each term. Okay, so let's put a1, and then we've got r to what power? Well, if we want to get on what for n is equal to 1, we want to get a1. Well, then r for a1, r needs to be 0, or the r needs to be raised to the 0 power to give you a 1. Then 1 times a1, right? So if we're starting at 1, put 1. Make sure you have this exponent goes to 0 for n is equal to 1, and then n is equal to 2. It's r to the 1. N is equal to 3, and so you could see how you could, for any starting integer, you could just write this out. Just make sure that the initial term, this r, the exponent of this r, goes to 0. Okay, so what we've got is adding what they give us. You've got 7 times 2 to the n minus 1 power. Okay, so I mean, it might not have been necessary to do to write this formula, because we could have just said, okay, we start at, we should have done this. This was overkill for this problem, but if we're just, the question is asking us to write the first 5 terms of the geometric sequence. So it starts at 7, and then r is equal to 2, just multiply by 2. Multiply each term by 2, and then 28 times 2 is 56, and then 56 times 2 is 112. Yes, we probably didn't need to do all this, but you get the idea. So, okay, read the first 5 terms of the geometric sequence based on the given information. Okay, so same as last problem. Same type of problem as last problem. So we start with a1 is equal to 36. Okay, this is a geometric sequence. It tells us that, but it doesn't give us an r. What does it tell us? It says that it gives us this a sub n is 1/2 times a sub n minus 1. We're looking for that common ratio. So what is r? Okay, in terms of a sub n minus 1 and a sub n, it's whenever you take a sub n and divide it by the term before it, you get r, right? So let's solve for a sub n divided by a sub n minus 1. What do we get? So if we just divide both sides of this by a sub n minus 1, one half, that is our r, right? So let's just, okay, so 36 times r is 18. 18 times r is 9, and then 9 times r is 9/2, and then 9/2 times r is 9/4. That's the first 5 terms. Okay, write a formula for the nth term of the geometric sequence. Okay, so now we're going to do the a sub n. So in a couple of problems ago, we kind of went over the how to write the a sub n for a geometric series. So I'm not going to go over it again. Just go back about a few minutes in this video. But okay, read your problem. What's the problem asking? It's telling us that this is a geometric sequence. So there should be a common ratio here. To go from 5 to 10, we multiply times 2. To go from 10 to 20, we multiply times 2. To go from 20 to 40, we multiply times 2. Okay, so we've got an r of 2. What else are we given? Well, we know the first term, right? So a sub 1 is equal to 5. Okay? So using the formula for the geometric sequence, the general a sub n formula, okay, put your a sub 1, okay, and now do r to the n minus 1. And that's it. There's your a sub n. Okay, same problem. We should be able to find there should be a common factor here. So to go from 18/6 to minus 16 to minus 6/5, what do you multiply by? So that would be what? Minus 1/3. Or no, minus 3. Minus 3. Oh, no. I'm sorry. No, minus 1/3. That's right. Yeah. Okay. So now if you multiply this minus 6/5 times minus 1/3, what do you get? That's right, 2/5. And then 2/5 times minus 1/3, you'll get negative 2/15. Okay. So again, we've got an R of minus 1/3. And then they also give us the A1. Okay, so formula for a geometric sequence, put your A1. Okay, now the R to the N minus 1. And that's your answer. All right, doctors in a certain state report 24 confirmed cases of the flu to the health department. Okay, at that time, the health department declares a flu epidemic. All right, if the number of reported cases increases by roughly 30% each week thereafter, find the number of cases 10 weeks after the initial report. Round to the nearest whole unit. Okay, so this, you have to read it very carefully to understand exactly what they're saying. So, and make sure you're applying your formulas correctly. So what I mean is, this is confusing because it's tempting to say, okay, we start at A1 is equal to 24, and then we increase by 30% thereafter. But it's saying that the doctors in a certain state report 24 confirmed cases of the flu to the health department. Okay, and then so like after the first week, it increases by 30%. Okay, so like you can look at that as your A sub 1. You can look at your A sub 1 as 24, but then we're going to be needing to solve for A sub 11, you see? But if we say, so 24 times 1.3, 31.2. So after the first week, there are 31.2 confirmed cases of the flu. You see? You see how that's tricky? You could start at A sub 1 equal to 24, but then that's kind of like an A sub 0. And you could say you're starting at A sub 0, but then you have to revise the formulas. Like, you can do it whatever way you want. Like, honestly, I mean, let's do that. Let's say, you don't have to start at A sub 1. So we're going to say that A sub 0 is 24. Then A sub 1 is 31.2. And then 31.2 times 40.56. Okay, and we'll round at the end. So I'm not rounding right now. I'm going to keep the decimal places, but then at the final answer we'll round it. Okay, so multiply this times 1.3, 52.73. Or maybe we should round it. I mean, you wouldn't. How do you have 40.56 cases of the flu? But I guess whenever whenever you're doing the, so yeah, like, okay. What you should do is you should report, like, okay. So this is 31. Okay, but whenever you're doing your multiplication, don't do 24 times 1.3, so 31. But then whenever you multiply it again, leave the 31.2, right? You see, don't do 31 times 1.3. I mean, that might still work, but just for the sake of the mathematical model of that's increasing at roughly 30% each week. So now I'm gonna do 41. I'm gonna write 41, round up, but then multiply to get the next term. Multiply 40. Don't multiply 41 times 1.3. Multiply 40.56 times 1.3, and you get 53. Okay, but now we're starting at n is equal to 0. Okay, and going to 10. Right? You start n is equal to 0, and then after the first week, after the second week, after the third week. So there's 11 terms, but if you start n is equal to 0, you can do this, but you just have to, the form, the a sub n for a geometric sequence, you're going to have to, it's going to be a little different than what you've been using, and you can do that. Okay, and so we're multiplying, again, roughly by 1.3 each time. That's what it says, roughly 30%. Okay, so R is equal to 1.3. So the number of cases after 10 weeks after the initial report. So it's saying what is the 10th term? Okay, so what is our a sub n? Okay, we've got A1, 24, times R, 1.3, and we just want our first term, we want this exponent to be 0, so we can just put n, not n minus 1, because we're starting at 0. You see? So 0, we start with 24, and then after the first week, you do it's 24 times 1.3 to the 1 power. That's exactly, okay? So now just put in a sub 10, or put in n is equal to 10. That's what we're looking for. So okay, so 1.3 to the 10th times 24, so 331. We're going to round up. 331. Okay, find the indicated term of a geometric sequence from the given information. So we know it is a geometric sequence, right? It doesn't, it's telling us it's a geometric sequence. So we're starting at 1, and that's usually a sub 1 r to the n minus 1. So 2 r to the n minus 1. And then, but we know this is equal to 2. A sub 1 is equal to 2. And then, okay, so now we could say, well, we know a sub 4 is equal to what? A sub 1, so 2 times r to the, okay, we could have plugged in a 1 here, so this would be, because we know the n, right? We know this is a sub 1. So we could have said 1 minus 1, this is r to the 0. And then here, n minus 1, so r cubed is equal to what? 16. Okay, so now divide both sides by 2. You get r cubed is equal to 8. So take the cube root of both sides. R is equal to 2. R is equal to 2. Okay. I mean, they gave us the A1, but like you're kind of here, you're kind of solving for A1. You could say you could have left this as A1, but they already gave us the A1. So, but you see, this is like, but okay. So we've got, what do we know now? We've got a sub n is equal to A1, a sub 1, 2, r to the n minus 1, but you can combine, this is 2 to the 1 times 2 to the n minus 1. So what you've got is a sub n is equal to 2 to the n, right? Because 2 to the first power times 2 to the n minus 1 power, you just add those exponents. 1 plus n minus 1 is n. Okay, so a sub 12, just plug in n is equal to 12, 2 to the 12. Okay, same problem as the last problem, same type of problem. So, well, it's a little different because they don't give us a sub 1. But just write out what you know, and then kind of write out everything you know, and then use all that information to solve the problem. So, all right, so we know the formula for a geometric sequence, a sub 1 that starts at 1 is a sub 1 times r to the n minus 1. Okay, so what do they give us here? Well, we know that r is equal to minus 2/3, so let's write an a sub 5 here. So a sub 5, so we substitute n is equal to 5. So we don't know a sub 1. Okay, we know r. All right, so the 5 minus 1. Okay, and they give it and they give us a sub 5. Right? So we have a sub 1 times minus 2/3 to the 4th power is equal to minus 16/9. Okay, so a sub 1. Okay, that's that 4. The 4th power is going to take away the minus sign. So 2 to the 4th is 16. 3 to the 4th is 81. Okay, so A1 is equal to, so you've got minus 16/9, and then dividing both sides, you've got 81 divided by 16. So minus 9. And that's what we're looking for. So that is your answer. Okay, so find A1 and R for a geometric sequence from the given information. So it's telling us it's a geometric sequence. Okay, so it looks like to me what we're going to do is we have our general formula for a sub n for a geometric sequence that starts at n is equal to 1. It doesn't tell us it starts at n is equal to 1, but that's kind of what you assume. That's usually the default. And then just write it out for these two cases, and we'll have two equations and two unknowns. So, in other words, so a sub 2, let's put, so we've got a sub 1, r to the a sub 2 to the 1 power is equal to what? 18. Okay? And now, let's, for a sub 5, okay, a sub 1, r to the 5 minus 1, 4, is equal to 144. So two equations and two unknowns. So let's divide a1 r to the 4th is equal to 144. Divide that equation by this equation here. So you get what? So you've got a1 r to the 4th divided by a1r is equal to 144 divided by 18. You see how you can do that? You can divide the equations, and it's still an equality because like you can, okay, like this equation here, I can divide both sides by the same number and it's still an equation, right? I can divide both sides by 2, can't I? Well, that's what you're doing. You're dividing this side by 18, and you're dividing the other side by this, which is equal to 18, based on this equality. So these cancel. You get r cubed is equal to 144 divided by 18 is equal to 8. So take the cube root of both sides, and we get that r is equal to 2. Okay, so now let's plug r is equal to 2 here and solve for a1. So you get 2a1 is equal to 18. So a1 is equal to 9. So there you go. You got a1 and r. That's what it's asking. Okay, find the sum of the geometric series if possible. So it's not like going to infinity. It's just this like the partial sum, which you could do with a calculator, but it's just trying to give you practice, right? If you were trying to find the sum of a finite geometric series with 1,000 terms, well, then it'd be nice to have a formula for that. But you don't. This you can just put into your calculator, or maybe do by hand. But let's practice using the sum of the first n terms. But for this situation, we're going to do 1, 2, 3, 4, 5, 6 terms. But the sum of the first n terms of a geometric sequence is what? You should be able to derive that. If we showed how to derive it in the previous videos, but you can memorize it as well. Or you could look it up, right? You could look it up. You could Google this. You could have your algebra or your calculus textbook and just look it up. But this is not for a geometric series. Like, the terminology is a little confusing here. Geometric series, you think infinite number of terms. This is like a finite geometric sequence. So there's two different formulas. You can find the sum of a geometric series, infinite number of terms, but that's not what we're looking for. We're looking for the sum of the first n terms of a geometric sequence. And so that formula is a sub 1 times 1 minus r to the n over 1 minus r. Okay, and so again, we're going to be, and we know a sub 1 is 15. Okay, and we know 1, 2, 3, 4, 5. We know we're going to want to sum the first n is equal to 6 terms. So now we just need r, and it's telling us it's a geometric series, so it should have the same common ratio here. So 15 to 5. You're multiplying by 1/3. 5 to 5/3, you're multiplying by 1/3. 5 to 5/9, you're multiplying by 1/3. Okay, so r is equal to 1/3. So, okay, so just plug it in. So a sub 1, you got 15, 1 minus 1/3 to the, we're doing s sub 6, 1/3 to the 6th over 1 minus 1/3. Okay, so 15, 1 minus, so 3 to the 6th. I mean, we can just plug this in. So, okay. So 1/3 to the 6th. Okay, 1 minus times 15 divided by 1 minus okay, so this is, I mean, you can just leave it as 1820 over 81 to give the exact answer. So so 1820 over 81. Okay. From the sum of the geometric series, if it says if possible, right? So think about what that means. Well, it's always possible, but I guess for this one it might not be, because it's asking us to do the infinite sum. It's not. We talked about in previous videos. You can't find the infinite sum of a arithmetic series, right? Or arithmetic sequence, or the sum of an arithmetic series. Series means infinite. and we talked about why in a previous video, but you can, for a geometric series, you can under certain circumstances, and that circumstances, the r needs to be, the absolute value of the r needs to be less than 1. And so and it's interesting how we can prove, we did the proof for finding the sum of a geometric series, but the S sub n in that case for the infinite sum is a sub 1 over 1 minus r. That's it. Okay? So this is a geometric series, it's telling us, so there should be a common ratio going from 2 to 8, 4, multiplied by 4. 8 times 4 is 32. 32 times 4 is 128. So a mistake that I'm sure people would make is, all right, 1 minus 4 is minus 3. And then 2 divided, so minus 2/3. Well, first of all, that doesn't make any sense, right? Because you plug in 4. 1 minus 4 is minus 3. Then a1 is 2. So minus 2/3 is the sum of the infinite sum. What does that mean? You're getting positive numbers each time. 8 plus 2. No, this only applies if the absolute value of r is less than 1. So it's not possible, is the answer here. Okay, so maybe this is possible. So same question, going from minus 2 to minus 1/2, you multiply by 1/4. And then so now if we multiply by, because we're summing the terms, like we're taking each term of this sequence and summing it. So the first term is minus 2, the second term is minus 1/2, the third term is minus 1/8. If you multiply minus 1/2 times minus 1/4, you get minus 1/8. And so when you sum them, you're subtracting them. And then to go from minus 1/8 to minus 1/32, multiply by 1/4 again. So the r is equal to 1/4. And so you can find the sum of this geometric series. So S sub n, or it's not S sub n, it's just S. I don't know why I put n, because it's infinite, is a sub 1 over 1 minus r. Okay, and we know the a sub 1, right? They give that to us. Minus 2, so 1 minus 1/4 over minus 2. 1 minus 1/4 is 3/4. Okay. Okay. So minus 8/3. And this makes sense. It's going to be a negative number. So that's interesting, right? The infinite number of terms, you get minus 8/3. The sum of this infinite sequence, or this infinite geometric sequence. Okay, Raphael received an inheritance of $18,000. He saves $6,480 and then spends $11,520 of the money on college tuition, books, and living expenses for school. If the money is respent over and over again in the community an infinite number of times at a rate of 64%, determine the total amount spent. Okay, so this is kind of a confusing question. But what it's saying is, if you read it carefully, so he gets an inheritance, and then he spends this, and then so all that goes into the community. Like, if you're tracking those dollars, and so they're saying that all that $11,520 is respent over and over and over again, but only 64% of each time. Like, he spends $11,520, and then 64% of that is spent by the community, and then 64% of that, of what was spent that second time, is spent again, and that happens an infinite number of times. So determine the total amount spent. So again, this is going to be that we're going to be using that infinite sum formula, Okay, the a sub 1 is that first amount spent. Okay, that's the a sub 1. The r that we're multiplying it by each time is 0.64. You see, because like it's 64% is spent by the community, then 64% of that what was spent just before. So I mean, we could write out. I mean, you could write out this sequence formula. So 1,520.64 to the n minus 1. Like, so he spends it. That's n is equal to 1. How much is spent? 11,520. Then the community spends 64% of that. So how much is spent the second time? 0.64 to the 1 power times that. Then the community spends it again, spends what they spent the previous time again. So 0.64 squared times 11,520. So you're seeing how much is spent each time, and they say how much total is spent. So add all of it up, right? Each one of those terms, add it all up to see how much total is spent overall. So just use this formula: 1 minus 0.64, and then okay, so divided by 32,000. Okay, last problem. Suppose that an individual is paid 1 cent on day 1, and every day thereafter the payment is doubled. Okay, so it sounds like we're going to have on day 1, our a sub 1 is going to be 0.01. And then every day we're multiplying by 2 every day. So unless we're given some other information, I think this is accurate. So write a formula for the nth term sequence that gives the payment on day n. I mean, you could change this to pn or something, right? Pn. So, well, no, that's p1. Okay, but the payment on day n is equal to P1 R to the n minus 1. So Pn is equal to P1 R to the n minus 1. So that's part A. How much will the individual earn on day 10, day 20, day 30? Okay, so day 10, P10, earn not total, but like how much are they going to earn on that day? So P10 is equal to 0.012 to the 9th. Okay, so 2 to the 9th times 0.01, $5.12. Okay. Okay, on day 20, P20, just do 2 to the, well, let's write it out. So 0.012 to the 19th, n minus 1, right? So 2 to the 19th times 0.01, 5,243. Okay, now on day 30, it's just going to be the 2 to the 29th, right? So 2 to the 29th times 0.01. Wow, okay, yeah, so $5.4 million. What is the total amount earned in 30 days? So this is a geometric sequence, but we're doing the S of n. This is the formula for the finite sum of a geometric sequence. So 1 minus r to the n. Okay, so we have all of this information. We're doing S of 30. So S of 30, A1 is equal to, oh, well, this should be P. Okay, so 0.01, 1 minus 2 to the 30, all over 1 minus 2. Okay, so let's see what we got. 1 minus 2 to the 30 times 0.01 divided by 1 minus 2 is minus 1. So $10.74 million.